Good day, everyone. I am your instructor for Mathematics in the Modern World. I am Junior Joshua Dingbing, and today we will just continue week one, which is uh, sequences, which is part two of natural mathematics. So let's go with the next slide. We have only one objective. We have to distinguish arithmetic and geometric sequences, find a common ratio and difference, compute the nth term, and compute the sum of the first n terms, and solve basic applications. Let's go with the introduction. So sequences model real patterns such as salary increases, savings plans, installment payments, and population growth and depreciation. So there is an application in real life of sequences, and it is also observed. Now, this module focuses on two core types, the arithmetic and geometric sequence. Now, for arithmetic, it is constant addition or subtraction, while geometric is constant multiplication and division. Now, let's start with the key terms. No? So we have sequence. So sequence is an ordered list of lists or list of numbers following a rule. So let's have an example. So these are examples of sequences. As you can see, the first sequence 2, 5, 8, 11, and 14 is an arithmetic sequence because it follows a rule wherein you add or you subtract 3 on the sequence to get the next term. While the second one is a geometric sequence. It follows a rule wherein you multiply 3 on each term to get the next term. Now, let's go with the next key term, which is the term. So it is the number in the sequence or each of the number in the sequence. As you can see here, let's go back to the example. In the two sequences, the terms are 2, 5, 8, 11, and 14, while on the other sequence, 2, 6, 18, 54, and 162. So these are the terms. So it is just the number inside the sequence or the numbers inside the sequence. Next is, and the term is denoted by the variable n. So let us remember that. Now, the next term or key term would be the nth term or a sub n. It is the term in position n. So here, let's go with the two sequences, the arithmetic and geometric sequence examples. So the terms are this one, and the nth term are this one. So that is the position of the term. So for example, a sub 1 is the first term, a sub 2 is the second term, and so on. Now we are familiar with the key terms. Let's go with the definition of the arithmetic sequence. So an arithmetic sequence is a sequence where the difference between consecutive terms is constant. As you can see in the example 3, 4, 6, 9, 13, 18, and 24, the uh, the sequence shows that there is a pattern. No? Now, the consecutive terms have a constant addition or subtraction of, or we should say common difference. Now let's go with the term common difference. So the formula for common difference is just a sub 2 minus a sub 1, where a sub 1 is the first term and a sub 2 is the second term. No? There is an example sequence which is 2, 5, 8, 11, and 14. So let's solve for the common difference. So we all know that the formula for the common difference is d is equals to a sub 2 minus a sub 1, which means it's the second term minus the first term. So our second term is 5, as you can see there in the sequence, and our first term is 2. So we subtract 5 with 2, that gives us 3. So our common difference for the sequence 2, 5, 8, 11, and 14 is 3. Now we're done with the common difference. Let's go with the next formula, which is the nth term formula. So this formula is used to solve for the nth term. So if you were asked for the 8th term of the sequence or the arithmetic sequence, this is the formula that you would use. Now the formula is a sub n is equal to a sub 1 plus the quantity n minus 1 times the common difference t, where a sub n is the nth term, which is the term that we need to solve. A sub 1 is the first term, n is the term number, and d is the common difference. Now let's go with the next slide and have an example. Now the example tells us we need to find the 10th term of 4, 7, 10, and 13. It is an arithmetic sequence since, as you can see there, using mathematics, using your eyes, there is a common difference of 3. Now, what's the first step? We need to list all of the given information. So the first term, a sub 1 is 4, a sub 2 is 7, and n is equals to 10. So n represents the term that we need to solve, which is the 10th term. Step 1, we need to solve for the common difference. Now, we all know that the common difference formula is d is equals to a sub 2 minus a sub 1, where a sub 2 is the second term, a sub 1 is the first term. Now, we substitute the values based on the given information. So our second term is 7. Our first term is 4. We have 7 minus 4, and the common difference is 3. Now we're done with step 1. Let's go with step 2, which is to solve for a sub n, which is, on this case, we need to solve for the 10th term of the arithmetic sequence for 7, 10, and 13. Now we all know that the formula for getting the nth term of the arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. Okay? Where our n on the based on the given information is 10. So we need to substitute the value of n with 10 and a sub 1 and also the common difference. Now, substituting all the information that we have on the given, we have a sub 10 is equals to 4 plus the quantity of 10 minus 1 times 3, which is the common difference, no? Not 3. Now, using PEMDAS, parentheses, we need to subtract 10 by 1. So we have a sub 10 is equals to 4 plus 9 times 3. Now, using again PEMDAS, we have to multiply first before adding the resultant, which is 9 times 3. 9 times 3 is 27. So we got 4 plus 27. And lastly, we need to add 4 and 27, and we got a sub 10 is equals to 31. So the 10th term for 4, 7, 10, and 13 is 31. Okay, so we're done with getting the 10th or the term of the arithmetic sequence. Let's go with the sum of the first 10 terms in the arithmetic series. Now we have a formula of s sub n is equals to n over 2 times the quantity of 2 a sub 1 plus the quantity of n minus 1 times the common difference d, where s sub n is the sum of n terms, a sub 1 is the first term, n is the number of terms, and d is the common difference. Now let's have an example. So we have an example here that we need to find the sum of the first 8 terms. So when we are, let's go back here, this formula is used to get the sum of the first n terms, meaning instead of solving one term, like in our previous example, we're solving for one term, which is the term. In the sum of the n series, we need to add the first n terms given in the problem. So we need to solve like the first 8 terms, 7 terms, instead of solving one term. Okay, now we're done with this one. Let's go back to the example. So find the sum of the first 8 terms, which is 3, 6, 9, and 12. Okay, so as you can see, there are 4 terms given. So we don't know the other 4 terms. To get the first 8 terms, then add it. Now, instead of doing that, we have a formula, the previous slide. I will just use it. Okay, now the first step is, of course, to list all of the given information. So we have the first term, a sub 1 is equals to 3. Second term is a sub 2 is equals to 6. And our n is 8. Where n, 8 is the number of terms that we need to get the sum. Now, step 1, solve for the common difference. We know that d is equals to a sub 2 minus a sub 1, where a sub 2 is the second term, a sub 1 is the first term. So on the given second term is 6, our first term is 3, so we have 6 minus 3, and the result is d, or the common difference, is 3. So that is our common difference. Now let's go with step 2 and solve for s sub n, which is the sum of the first 8 terms on this case. Now we have the formula, right? Let us remember that and be familiar with the formula. S sub n is equals to n over 2 times the quantity of 2 times the first term a sub 1 plus the quantity n minus 1 times d, which is the common difference. Now, we all know that the value of n is 8, so we need to substitute all variables of n with 8, and then a sub 1 is 3, And then our n is 8 and our common difference is 3. Okay? So we have S sub 8 is equals to 8 over 2 times the quantity of 2 times 3 plus 8 minus 1 times 3. Okay? So with that, we will follow the PEMDAS, parenthesis, exponent, multiplication, division, addition, and subtraction. So we need to execute and perform all operations based on that. Now, we got 8 divided by 2, that's 4. 2 times 3 is 6. And 8 minus 1 is 7. Now, we need to execute and use PEMDAS again. So we can multiply 7 and 3. So we got 7 times 3 is 21. Then we got S sub 8 is equals to 4 times the quantity of 6 plus 21. So here, we can add 6 and 21. So we got 27. So 4 times 27. Then we multiply 4 and 27, we got 100. So the sum of the first 8 terms is 108 for the sequence or arithmetic sequence 3, 6, 9, and 12. Okay. Okay, that concludes our arithmetic sequence. Let's go with the geometric sequence. So a geometric sequence is a sequence where the ratio between consecutive terms is constant. It means that if there is a sequence and if you multiply or you divide, no, a ratio in between them, in between consecutive terms, it is constant all throughout. Now, the formula for common ratio is R is equals to A sub 2 over A sub 1, no? Where A sub 1 is the first term, A sub 2 is the second term. So we have here 3, 6, 12, 24, and 48. This is an example of a geometric sequence, and we need to know the common ratio. We know that the given, we need to list the given information, which is the first term, A sub 1 is equals to 3, A sub 2 is 6. And we know that the formula for common ratio is A sub 2 divided by A sub 1. Now, second term, A sub 2 is the second term, A sub 1 is first term. So substitute, that is our second term is 6, our first term is 3. 6 divided by 3, we got 2. That is our common ratio. Now we're done with the common ratio. There is also a formula for the nth term, no, for geometric sequence. And the formula for that is A sub n is equals to A sub 1 times the common ratio R raised to the power of n minus 1. So where A sub n is the nth term, A sub 1 is the first term, n is the term number, and R is the common ratio. Now let's have an example. So here, the nth term again, let us have a recap. When we say the nth term, it means that we need to solve particular term or position of the term, no, of a given geometric sequence or arithmetic sequence. And in this case, this is a geometric sequence. Now, we are tasked or we are given a task that we need to solve for the seventh term of the geometric sequence 5, 10, 20, and 14. Okay? Now, first thing we do is list all the given values. A sub 1 is equals to 5, which is the first term. A sub 2 is equals to 10, which is the second term. And n is equals to 7, which is the position of the term that we need to solve. Step 1. We need to solve for R, which is the common ratio. We know that common ratio is equals to A sub 2 over A sub 1. Second term is 10. First term is 5. So we have 10 divided by 5. That is 2. Our common ratio, R, is 2. Step 2. We need to solve for A sub n. On this case, we need to solve for the seventh term. So we all know that the formula on the previous slide, A sub n is equals to A sub 1 times R raised to the power of n minus 1. That is our nth term formula for geometric sequence. Now we need to substitute. We know that our n is 7. So therefore, we substitute n on all variables with n. A sub 1 is our first term, which is 5. And n, again, is 7. So we got A sub 7 is equals to 5 times the quantity of 2 to the power of 7 minus 1. Using PEMDAS, we need to simplify the exponent first. That's 7 minus 1. So we got 5 times the quantity of 2 to the power of 6. Then using PEMDAS again, we need to execute the term with an exponent, which is 2 to the power of 6. 2 to the power of 6 is 64. Then we'll multiply the two terms. We got 320. So it means that the seventh term for the geometric sequence 5, 10, 20, and 40 is 320. Okay, we're done with the n term formula. Let's go with the last part, which is the sum of the first n terms in the geometric sequence. So if r is not equal, so it means no, that the equal sign with a bar or a slash, it means it's not equal, meaning r should not equate to 1. So S sub n is equals to a sub 1, which is the first term, times the quantity of r raised to n minus 1 all over 1. Wherein r should not equal to 1 because if it equates to 1, that is 1 minus 1, it would result to 0. So any number divided by 0 will be indeterminate or infinity. And it's not solvable. No? So in our calculator, it will show math error. So make sure that you check the series first before solving. No? What if the equation or the sequence is indeterminate? So there's no need for you to solve. No. So you have to observe first and check first the series if it's geometric, arithmetic, or indeterminate or cannot be solved. Now, S sub n there on the formula is the sum of the n terms. A sub 1 is the first term, n is the number of terms, and r is the common ratio. Now, let's have an example. Now, in this example, we need to find the sum of the first 6 terms of 2, 6, 8, and 54. So, in layman's terms, we need to, what? We need to add all of the values of the first 6 terms of this geometric sequence. Okay, now first, we need to list all of the given information. So we know that our first term is 2, which is a sub 1. Our second term is 6, which is a sub 2. And our n, which is the number of terms that we need to solve, is 6. Step 1. Let's go with the solution. Step 1 is solve for r, or the common ratio. We know that r is equal to a sub 2 over a sub 1. A sub 2 is 6. Our a sub 1 is 2, which is our first term. No? A sub 2 is our second term. 2 is our first term. 6 divided by 2 is 3. So our common ratio for 2, 6, 18, and 54 is 3. Now we're done with the common ratio. Let's go with the second step, which is to solve for the S sub n, or the sum of the first 6 terms on this particular case. That we all know, and we have discussed on the previous slide, that the formula for S sub n for geometric series is S sub n is equal to a sub 1 times the quantity of r raised to n minus 1 all over r minus 1. Now we all know that the value of n, which is 6, which is the first 6 terms, our a sub 1 is our first term, while our r is our common ratio. Now, substituting all the values given, n is 6, so substitute all n or variables of n with 6. Our a sub 1, or first term, is 2, and our common ratio is 3. So we got s sub 6 equals 2 times the quantity of 3 to the power of 6 minus 1 all over 3 minus 1. So using PEMDAS, simplify the equation. So we got s sub 6, that is 2 times 3 to the power of 6 is 729 minus 1. 3 minus 1 is 2. Okay? Now, 729 minus 1, that is 728. So we got 2 times 728 all over 2. So we multiply it 728 by 2, divide by 2, or really the easier way is just divide 2 by 2, and we got 728, or the sum of the first 6 terms of the geometric sequence 2, 6, 18, and 54 is 728. And that ends our week 1 part 2, guys. Thank you for listening, and I hope that you have understood understand our lesson for today. Thank you so much, and God bless.